chapter 10.3 deals with the properties of logarithms. And so the properties of logarithms are actually very similar to the properties of exponents that we've learned before. And so I'll just go ahead and give them to you. The first property of logarithms is that if I have a log that's base b, and let's say I have on the inside an m times an n, what that means is that I can separate that logarithm out to make it log base b of m plus the log base b of n. Similarly, if I have log base b of m divided by n, I can say that is log base b of m minus log base b of n. And then the only one that kind of deviates a little bit, if I have log base b of m to the n, what that means is that the n comes out in front and it gets multiplied by, whoops, not capital L, log base b of m. Now remember, just because these work in forward motion means that they also work in reverse motion. So if I have log base b of m plus log base b of n, I can multiply m and n together. Same thing here, I can divide m and n together, I can move backwards. All right, and I can pop this n back on as an exponent. Now, sometimes it's required for us to move forwards like this, but sometimes it's required for us to move backwards. So just keep your mind flexible. And then, it doesn't really appear as an official rule, but I always like to remind you that if I have log base b of b, that equals 1. All right, so just make sure you guys are keeping that one in mind. How are they going to give this to you in terms of problems? They might ask you to do something like this. They will say, given log base 3 of 5 is approximately equal to 1.4650, they might ask you to do a problem like this. Tell us what log base 3 of 45 is. Now from here you have to use your properties of logarithms in order to figure this out. What we're going to do is I'm going to identify log base 3 of 45. I'm going to identify 45 as, say, 9 times 5. All right. Now, another way I can identify this is log base 3 of 9 plus log base 3 of 5. Well, log base 3 of 5, they gave that to me. That is going to be 1.4650. That's what this thing becomes. I'm going to add this to, well, log base 3 of 9, they didn't give me anything based on that, but I can further manipulate log base 3 of 9 to become log base 3. Well, 9 is really 3 squared. Now I'm going to use this property of logarithms, and I'm going to back this 2 down. So I have 2 log base 3 of 3, and don't forget I have plus 1.4650. Well, log base 3 of 3 is 1, so that's going to go away. I have 2 times 1, which is 2, plus 1.4650. So when all is said and done, log base 3 of 45 is approximately equal to 3.4650. So let's try another one of those. These are kind of neat. So I'm going to separate this out. If I was asked to find the log base 3 of 25, now I hope you guys wrote that down, that log base 3 of 5 is equal to the 1.4650. This one's a little easier. What this is this is log base 3 of, say, 5 squared, all right, because 25 is 5 squared. I'm going to back the 2 down, so I have, actually I'm going to move this down, 2 log base 3 of 5, and log base 3 of 5, they gave that to us. That's 1.4650, and don't forget that's being multiplied by 2. And so what I get is 2.9300. All right? Okay, they might up it a notch and give you 2 logarithms now. I have given log base 3 of 2 equals 0.6310, and log base 3 of 7 equals approximately 1.7712. They might ask you to do something like find the log base 3 of 49. Well, that's a piece of cake. It's similar to the last problem. That's log base 3 of 7 squared, which is 2 log base 3 of 7, right? I'm just using the properties of logarithms, right? The 2 backs down to become here, and then 3. Now, log base 3 of 7 is approximately 1.7712, and that's going to get multiplied by 2. Well, that's going to equal approximately 3.5424. And next on the agenda is going to be log base 3 of 18. Well, I can go ahead and use a couple of properties of logarithms here. I can say log base 3 of, say, 9 times 2. Well, that's log base 3 of 3 squared times 2. Now, now I can separate this again, sorry. Log base 3 of 3 squared plus log base 3 of 2. Now, I'm going to go ahead and move downwards now by moving the 2 out in front, log base 3 of 3 plus log base 3 of 2. Well, log base 3 of 3 is 1, so that's 2 times 1, which is 2, plus log base 3 of 2, well, they gave that to us. That's approximately equal to 0.6310. So my total answer is going to be 2.6310. Let's do something a little more tricky. Log base 3 of 54. And that's going to be something like log base 3 of, let's say, 2 times 27. Because log base 3 of 2 is already given to us. It's this 0.6310 stuff. And so I'm going to go ahead and go log base 3 of 2 plus log base 3. Now 27 is really 3 cubed, right? And now I can go and back this 3 down and say log base 3 of 2 plus 3 log base 3 of 3. That's going to go away. It's 3 plus 0.6310, which is 3.6310. Okay, let's do one more that's a little bit trickier. I want to keep this 0.6310 because I don't want to keep scrolling. Number 4 here, if I say log base 3 of 18 over 49. Let's go ahead and separate this out. This is log base 3 of 18 minus log base 3 of 49. Well, actually, if you look back at example number 2, we already did log base 3 of 18. So I'm not going to do it again. It's 2.6310. Now, we also did log base 3 of 49 a little while back. Log base 3 of 49 was 3.5424. Just look back towards example 2. So I'll even write this down. Example, this looks like example 3, and then this is example 2. All right, so go and just keep that in mind. So I'm going to go and subtract them now. That is a negative 0.9114. And that's it. All right, let's take a look at how we're going to use this to solve equations of logarithms. Okay, so I hope you guys wrote down your properties of logarithms because we're going to use them to solve these logarithmic equations. Now, the most important thing you guys need to know is that we use the properties of logs more so to consolidate logarithms. All right, and so rarely do we ever expand logarithms during these equations. We want to get things as small as possible. So what I'm going to do is I'm going to identify that we're all dealing in log base 3 here, first of all. Second thing is that the log base 3's here, they have a 2 and a 7 and they're being added, which means that really in between them there's multiplication happening. So that means that I can really rewrite this as log base 3 of 2 times 7 equals log base 3 of x. Now 2 times 7, well, that's a no-brainer. That's log base 3 of 14. and that's going to equal log base 3 of x. Now we're back to chapter 10.2, where if I have the same log bases on both sides, they can kind of get out of there, and you end up with x equals 14. All right, so again, most of this is just consolidating logarithms together into something that is more manageable. So if I say I have log base 5 of m equals 1/3 log base 5 of 125. Well, here I'm going to use my reverse property of log, and I'm going to go ahead and back this 1/3 into here. So I have log base 5 of 125 to the 1/3 power, and that's going to equal log base 5 of m. Now 125 to the 1/3 power, that is log base 5 of 5, right? Because the cube root of 125 is 5, and that's log base 5 of m. Now again, I've got two logs that have the same bases, so I'm going to get them out of there. So I have m equals 5, and that's as far as you go. Okay, so if I have this here, again, I'm going to go and consolidate my logarithms. I've got two logarithmic expressions on the left side, so I have to consolidate. They're being added, which means that I can multiply the answers. So I have a single log base 9 of 5 times n plus 1 equals log base 9 of 6n. Now I'm going to go ahead and distribute here. And because I only have one log on both sides, I can go and cancel them out. So I have 5n plus 5 equals 6n. So n equals 5. Now, one thing I want you guys to keep in mind is that, remember, I am consolidating first before I cancel the logarithms out. Do not cancel out and then consolidate. This is not 5 plus n plus 1 equals 6n. Consolidate first, then cancel the logarithms. All right? So keep that in mind. I'm going to say it a bunch of times so that hopefully you don't forget. I want you to have dreams of consolidating logs before you cancel them out. Let's do another one. Number 3 here, we've got log base 6 of 48 minus log base 6 of 16 over 5 plus log base 6 of 5 equals log base 6 of 5x. So let's go ahead and take care of this one operation at a time. I'm going to work from left to right here and deal with this first. This is really log base 6 of 48 divided by 16 over 5. Now I'm going to go and rewrite this again because this is log base 6 of 48 times 5 over 16. Those are going to cancel each other out. I have a 3 up top. 48 divided by 16 is 3. So what I really have is log base 6 of 15. And that's what happens when all of this is done. Log base 6 of 15 plus log base 6 of 5 equals log base 6 of 5x. Now I'm going to go ahead and multiply those together and consolidate my logarithms because I consolidate before I cancel. I have log base 6 of 15 times 5 is 75, and that's going to be equal to log base 6 of 5x. Now that I have a single logarithm on both sides, now I can get them out of there. 75 equals 5x, and therefore x equals 15. With number 5 here, we've got something a little funny happening. In the past, we had logarithms on both sides. Now this time we don't. So that means that the dynamic of this problem is going to change a little bit. But let's do what we know. I've got two log base 6s on the same side. They're being added, which means I'm going to go ahead and multiply those two terms together. Now I have log base 6 of 2 parentheses b squared plus 2 equals 2. Now I could distribute in, but I'm not going to do that just yet. Whenever I'm stuck, I want to focus on this idea of being stuck here. I've got a log base 6 of this garbage right here equals 2. Remember, the 6 is your base. Your exponent is the number 2. This is your exponent. And that's going to equal your answer, which is 2 parentheses b squared plus 2. So now I'm going to go ahead and hash this out. This is 36 equals 2 parentheses b squared plus 2. I'm going to divide by 2 on both sides. I get 18 equals b squared plus 2. Let's go and subtract 2 from both sides. I get b squared equals 16 and b equals plus or minus 4. Now, because I ended up with two answers and because there's a b on the inside of the answer, I got to check. If I plug a positive 4 into there, I get something bigger than 0. If I plug in a negative 4, I square it, so I get positive 16. It's still bigger than 0. I'm good on both answers. Okay, there is your properties of logarithms. We'll see you next time.